The angle of elevation from a kicker's foot on the football field to the top of the goal post bar is 17 degrees. If he's standing 131 feet from the base of the goal post, how tall is the goal post? All right. So I like to show some clip art in here to make sense of it. So no matter what, we are always making a right triangle. Let me make this better. All right. So since it's with the ground, we're at the bottom where his foot is, okay? It makes a 17-degree angle with the ground. So there's your angle. He is standing 131 feet from the base. Distance from standing from anything is always a distance on the ground. So that 131 is right here. That's distance from. Distance from is always parallel with the ground. It is always on the ground. How tall is the goalpost? So the goalpost is over here. So there's your goalpost. Everybody's, if you don't like football, you've seen a field goal post. So you're looking for height. Anything that's height is always our vertical line. So this would be, if I wanted to set this problem up, I would do tangent because I have opposite and adjacent. So my formula would be tan 17 equals x on top of 131. So that one is ready to go. All you have to do is punch a few buttons in your calculator and you have it done. Leah's mom is standing at the bottom of the slide of the playground, waiting for Leah to slide down. The angle of elevation from the bottom of the slide to the top is 46 degrees. Then the slide has a vertical height of 9 feet. Find the length of the slide. Okay, got my jacked up looking Leah. So I'm going to shrink her and I'm going to put her at the top of a slide. Okay, so I got a right angle. I'm going to have a right triangle. All right. So let's see where these numbers go. So I got a 46 degrees. That's important. The angle of elevation from the bottom, here's the slide right here. This is the slide. This is what we slide down. Everybody knows that. The bottom of the slide to the top is 46 degrees. The angle, it says angle of elevation. That means we put it on the bottom. So there's where your 46 goes. Every angle of elevation goes down there. And the slide has a vertical height of 9 feet. Vertical height, as a vertical goes straight up and down. There's your 9, vertical height. Find the length of the slide. Well, the slide we already said is this blue line right here, so you're actually finding the length of the slide. So this is always the slide. This is always kite string as well. Any kind of wire or kite string or slide or a ladder is always the hypo. Ladders lean. Okay, kite strings never go straight up. Wires never go straight up. They're always at an angle. So I would say that this is opposite. This is hypo. And I would use tan. So my equation is tan 46 opposite over x. And that is what the equation, that's the equation that would get me the length of my slide. All right, so on that previous one, we did catch a mistake, and it's not tangent, it is sine. I went too quick and called that tangent. So let's move on. A dog is standing 5 feet from the base of a tree, looking up at a cat. So I got my dog down here, I got my little cat in that tree. So he's standing 5 feet from the base. So let's go ahead and make a base of 5 feet. He's standing 5 feet from the base of a tree. Looking up at a cat, there's my cat right there. that has climbed 16 feet up the tree. So yes, this picture isn't very well done, but it doesn't matter. It's just a representation of what we're looking at. What is the angle of elevation from the point of the dog is standing on the ground to the cat? Okay, so my angle, so now we're focused on the angle. So now we're actually looking for this guy. So here is not, so the previous two problems were finding sides, and now we're finding an angle. So once again, this is going to be opposite, adjacent. This is going to be tangent. So we would say the tangent of my angle x equals opposite over adjacent. And this is where we would hit second and need to see the inverse operation in our calculator, the -1 there. All right, Timmy's flying a kite with an angle, with a 22-degree angle of elevation with the ground. All right, so we got a jacked up looking Timmy. I always like to use funny pictures. We got Timmy. We got our kite. We're going to have a kite string. Ooh. And then we got our right triangle. So the kite string makes a 22-degree angle with the ground. If he lets out 124 feet of string, okay, remember, usually this isn't perfectly straight, but there's our string. String, rope, wire, and ladder are always hypos. They're always leaning. They're never straight up and down. So this is the 124 feet of string. How high is the kite off the ground? A height is always a vertical line. So there's your height. I'll use H for height. So this one is going to be sin. So, or sine. Sine of 22 equals height over hypo. So there's your equation that you'd use to find the height that the kite is off the ground. Here's our first angle of depression. A pilot in a helicopter spots a landing pad below. So I'm going to move my helicopter. We got our landing pad probably on top of a building or maybe just out in a field somewhere or in an airport. If the angle of depression is 73 degrees, so let's make our triangle. So we got our vertical height, our distance from, and we'll just go ahead and complete the right triangle there. Angle depression is 73, so that's out here. But we're never going to use that. I'm going to use alternate interior angles and put that 73 here, and this is the angle that I'm going to focus on, not the 73 outside. So let's continue with our problem. And the horizontal distance, so the distance from is 1,200 feet. Horizontal distance, distance from, even though this helicopter is up in the air, distance from is always on the bottom. And now I'm going to continue to put it there. What is the altitude of the helicopter? That is height. Altitude is height. So this is another tangent problem. So we got our angle, we got our opposite, we got our adjacent. To solve this, we would use tan 73, our angle, opposite over 1,200. Moving on to our second. All right, so watch this one. This one I try to make a little tougher. Building A is 480 feet tall and building B is 654 feet tall. All right, so let us make some space here between A and B. So I'm going to have A being 480, and I'm going to have B being 654. If the angle of depression from the top of angle B to the top of angle A is 42. So what they're saying is there's a right triangle in here. Okay, so here's where our right triangle exists. From the top of angle A, of building A, and then there's a top here. So you should see that there's a difference here. You should see that we got a 480. We got a 480 that we have to consider from this 480 over here. So here's where I was talking about this earlier. This is where this is going to come into play. If the angle of depression from the building of B to the top of A is 42, so that is out here. It's never inside. Angle of depression is always outside. And we do our alternate interior angles and put it inside. And then I'm going to ignore this. How far apart are the buildings? So I need this. So if I was to delete all this and erase all that, I can't do that math. I need another number. Here's where that number comes from. That number, I can find the length of this piece right here by taking consideration if this is 480 and the whole thing 654, wouldn't this piece be 654 subtract the 480? So let me grab my calculator. 654 minus 480 is 174. Now, after all this stuff is there in this picture and helping me, it boils down to this picture. Finding the distance between the two buildings. And this is another tangent. Because this is opposite and this is adjacent. And I said that tangent is going to be 3/5. This tangent's going to show up 3/5 of the time. Majority of the time it's tangent. So tan 42 equals opposite over adjacent. And that would be our problem with the buildings. So that one was a little more complicated, but I hope all the pictures and all the detail that I put in the picture helped. Next, angle depression. Jack is standing at the top of a lookout tower and spots a water fountain below. So he's sitting up here, you can see him. Got my water tower, let's make a little gap here. If the lookout tower is 75 feet tall, okay, I can do this. Let's make a triangle. So I got a 75 here. Gotcha. And the angle of depression is 28. Okay, so our angle of depression goes outside, but then I know I can drop it to the bottom using alternate interior angles. And this is ignored now. What is the horizontal distance between Zach and the water fountain? Remember, distance from is always on the bottom. And that is our picture. So ignore this stuff. There it is. And once again, we have a tan. We have an opposite. We have an adjacent. We say tan 28 equals opposite over adjacent. Let's go to my last one and get this over with. Cam was on top of a building. Well, I'm just going to let you know I made this one up. Other ones I kind of took from ACT booklets and stuff like that, but this one, he's going to put a camel on top of a building, not sure, but I hope you think it's as funny as I do. Okay, so I got a camel's up here on top of a building. I can put the building here if I want, but looks like I'm going to have a triangle that goes, since the camel's on top, that means, let's see if my chicken is on the ground. It is looking down at a chicken that is 84 feet from the base. 84 feet from the base. Distance from. Here's the base down here. Here's the chicken down here. 84 feet from the base. So there's one piece of my triangle. All right. Camel's on top of a building. It's looking down at a chicken that is 84 feet from the base. Camel standing on. What's the angle of depression from the camel to the chicken? Well, what's the angle of depression? So that means I can put it down here. And that is the angle we would actually find, and it would be the answer. And I'm going to ignore this one. But here's the problem. As I look at my question, I left something out. I forgot to put the height of the building. So let's just say the building is a short building. Let's say it's like a convenience store. We'll just say 20 feet. So I'm adding that. As I was typing this, I must have forgot to add the height in there. And that would be our problem. Got our, ignore these pictures now. Focus only on the triangle. So that would be tangent again. Opposite. Adjacent. But it's going to look different. So now this is where we would do the inverse operation and make sure we saw that on our calculator.